Hey everyone, and welcome. So, if you've ever played around with ChatGPT, or maybe Claude, or Gemini, then you've already used a large language model. Today, we're going to pull back the curtain and see what actually makes these incredibly powerful AIs tick. Let's dive right in.
To get a sense of why this is such a big deal, just look at this number, 100 million users in 2 months. I mean, that blows Instagram out of the water, it's faster than Spotify, it's faster than pretty much anything we've ever seen before. So yeah, LLMs aren't just some niche techie thing, they're a global phenomenon, and honestly, understanding them is becoming absolutely essential.
So here's our game plan. We're going to start with the basics. What are these things? Then we'll figure out where they fit in the whole AI family tree and uncover the surprisingly simple secret that powers all of them. After that, we'll get into how they're trained, and finally, we'll talk about the good, the bad, and the fake, so you know how to use them as a tool and not get tripped up.
All right, first up, what exactly is a large language model? You know, the key here is to really grasp this fundamental shift in how computers work. For decades, we've told computers exactly what to do with explicit instructions. But now, we've moved into this whole new world of probabilistic predictions.
Okay, and this is the most important thing to get. When an LLM gives you an answer, it isn't thinking. It's not understanding a concept the way a person does. What it's actually doing is performing unbelievably complex statistical calculations. It scanned trillions of words and has gotten so good at recognizing patterns that it can predict, with just uncanny accuracy, what the next most likely word ought to be. It's like a superpowered mimic, not a conscious being.
You hear all these terms thrown around, right? AI, machine learning, deep learning, and people use them kind of interchangeably, but they're really not the same thing. To see where LLMs fit in, it really helps to think of them like a set of Russian nesting dolls, where each one is a more specific version of the one before it. So at the very top, the biggest box, you've got artificial intelligence, or AI. That's just any machine doing anything that seems smart. Then, inside that box, you've got machine learning, which is when systems learn from data instead of being explicitly programmed for every little thing. Go one level deeper and you find deep learning, which uses these really complex, multi-layered neural networks. And finally, right in the center, you have LLMs, a very specific kind of deep learning that's laser-focused on language.
Okay, now for the part that really peels back the layers of mystery. Behind all the insane complexity, the billions of data points, the massive supercomputers, there's a surprisingly simple, almost elegant secret at the very heart of every single LLM.
So what is it? What's the secret behind all this magic? I mean, how does a machine write poetry, or debug computer code, or explain quantum physics to a 5-year-old? What is it actually doing under the hood?
And there it is. That's the secret. At the end of the day, they are just the most powerful, most sophisticated autocomplete systems you've ever imagined. When you type in a prompt, all it's doing is predicting the next most probable word, and then the next, and then the next. But here's the crazy part. When you scale that simple idea up with a model that's been trained on basically the entire internet, something truly incredible starts to happen.
And this is a great breakdown of how it works in practice. So you give it a prompt, your words get broken down into these numerical pieces called tokens. Those tokens get fed into the neural network, which runs billions of calculations to figure out the probability for every single word it knows. It then picks the most likely one, adds it to the sentence, and then does the entire thing all over again for the next word. And it does all of that in milliseconds. It's wild.
So how in the world do these models get so good at just predicting the next word? Well, the training process is this really fascinating journey that unfolds in 3 very distinct stages. You can kind of think of it like raising a kid who eventually grows up to become this world-class, super helpful personal assistant.
The first stage is also the biggest and by far the most expensive. It's called pre-training. Basically, the model is fed a gigantic slice of the internet. Books, articles, code, you name it, and it's given one simple task, over and over and over. Here's a sentence with a word missing, guess the word. By doing this trillions of times, it learns grammar, facts, and even basic reasoning. But at this point, it's like a genius scholar who's read every book in the library but has 0 social skill.
That's where stage 2, fine-tuning, comes in. This is where humans step in and give the model thousands of really high-quality examples of how a helpful assistant should act. It learns to follow instructions, to answer questions directly, and to adopt that helpful, conversational tone we're all used to. This is basically where it learns its customer service skill. And the final stage is what many consider the real magic sauce, reinforcement learning from human feedback, or RLHF. Now here, humans aren't writing the answers anymore. Instead, the AI generates a few different responses, and the humans just rank them from best to worst. The model then learns to optimize its answers to get a better score from the humans, which makes it more helpful, more honest, and a whole lot safer.
And this table just puts it all together beautifully. Just look at the insane difference in scale. The pre-training takes months and can cost over $100 million just to build that raw engine of knowledge. Then, the much faster and cheaper stages, fine-tuning and RLHF, take just days or weeks to teach that raw intelligence how to actually be a useful, aligned assistant for people like us.
The growth here has been just staggering. The brain size of these models, which we measure in something called parameters, has absolutely exploded. From GPT-1 to GPT-4, we're talking about a 15,000-fold increase in just 5 years. That's not a typo. That sheer scale is one of the biggest reasons their abilities have improved so dramatically.
And of course, that kind of scale comes with a jaw-dropping price tag. The cost to train one of these flagship models has gone from, $50,000 to well over $100 million. And that's not just a fun fact. It has real consequences. It means the power to build these foundational models is really only in the hands of a few very wealthy companies. And that reality shapes the entire AI landscape.
Okay, so now that we have a sense of how they're built, let's get practical. Because to use these tools well, you absolutely have to understand what they're great at, where they completely fall apart, and where they can be dangerously wrong.
LLMs are phenomenal creative partners. Seriously. They are amazing at things like drafting emails, summarizing long articles, brainstorming a bunch of ideas, or even helping you write and debug code. Because they've seen countless examples of these things, they are masters of recognizing and generating patterns in language. But, and this is a really big but, they have some critical blind spots. They are not calculators. They predict numbers, which means they often make simple math errors. Their knowledge is frozen in time. It literally has a cutoff date. And most importantly, you have to remember this. They are optimized to sound plausible, not to be truthful. And that leads to their single biggest flaw.
This right here is what we call a hallucination. The AI will confidently, and I mean confidently, invent facts, sources, and statistics that look 100% real but are completely made up. It's not lying because it doesn't know it's wrong. It's just generating text that fits the pattern of a real citation. This is the #1 danger you have to be on the lookout for. And all of this brings us to the most important takeaway of this whole thing. We have to treat these models as incredibly powerful tools, not as some kind of magical oracle that knows everything. They absolutely require our judgment and our critical thinking to be used safely and effectively. So let's break it down. Do use them to speed up your work. Do use them to write a first draft that you can then edit and refine. Use them to explore new ideas. But please, do not let them replace your own judgment. Don't trust unverified facts. Never, ever cite them as a primary source without checking. And for goodness sakes, don't use them for critical medical, legal, or financial advice.
And that's our look at large language models. At their core, they are the most sophisticated pattern matchers humanity has ever built. They're becoming masters at recreating the patterns of human language. So we'll leave you with this question to chew on. What happens when the patterns they master are no longer just our language, but the very patterns of our thoughts themselves? Thanks for watching.